Hi guys, welcome back. Today we'll be discussing about the last question of OMK 2015 Bongsu. This is the hardest one on the test. And then we would like to solve this problem, then get on with it. And then next week we'll be discussing about OMK 2015. But this time it's smoother, means it's specifically targeted for Form 3 and Form 4 students. So okay, let's see what the problem tells us. Very deceptively simple because there's only just one short sentence right here. Find the last two digits of 11 to the power 11 to the power 11. So this is a very big number. As you might guess, this is very astronomical. So what I like the last two digits of 11, 11, 11. For last two digits, okay. Prior to that, I'd like to introduce a concept called modular arithmetic. I'll put some links in the description to link to other videos to let you guys have a stronger understanding on modular arithmetic, but I won't be talking much about it here. But just for a simple introduction, maybe when we say, for example, 37, when divided by 4, it has a remainder of 1, right? Right, so we can write 37, 9 times 4 plus 1. So 37, we also can write it as 37. This time we do not need to care about the divided, the they say quotient. We do not need to care about quotient, but we only need to care about the remainder. So 37 is, here we say, congruent to 1 mod 4. So yeah, this is about it. This is the basic understanding of modular arithmetic. And we will be using modular arithmetic to deal with this problem. So for last two digits, we can say, okay, for last two digits, let me give you an example. 941. So what are the last two digits? 41, right? We will be using mod 100 to deal with problems involving last two digits. And then for last digit means dealing with mod 10. And then for last three digits, we'll use mod 1000 and so on and so forth. Because 941 over here is 900, which is itself a multiple of 100 plus 41. So 900, we can eliminate it, like something like this. So what we want is the last two digits of 11, 11, 11. I'm not pronouncing it the right way, but I think you get it. So what we would like, ideally, is to find a recurring sequence, a pattern which repeats itself, so that we can remove the hassle. So let's see what we have. From now on, for mod 100, I'll just be using this sign, and then give me some time, I'll write some stuff over here. Okay, so just to save you guys time, I've written quite a lot of stuff over here, but no worries, I haven't written any important information inside yet. So let's work along. Okay, so for 11 to the power of 1, which is itself, when dealing with mod 100, this is mod 100, just to remind you, it will have a remainder, it will be congruent to 11 mod 100. So 11 squared, 11 times 11 is 121, right? So it will be congruent to 21 mod 100, just taking out the last two digits. Then 11 to the third power, we don't need to care about 121 times 11 equals to what already. We just need to find 21 times 11. It will be 31. Then so on and so forth. We just need to repeat the process. Just filling out stuff over here. Because if I were to write those without pausing, it will take up a lot of time, which is what we don't want. Okay, up to here we can see it's already 0, 1, and then see what comes next. So, okay, wait, this is something very special. We have 11 here, but then at the first place we have another 11 also. So which means we have already found our recurring sequence. We can see that it repeats for every 10 powers. So for every 10 consecutive powers, the sequence repeats itself, it's a cycle. So, okay, this is what we have found. Okay, so what we want to deduce is what would be this number here, mod 10, because we know that's 10 numbers per cycle just now. So actually, you can see that 11 is congruent to 1 mod 10, right? 10, to remind you, 10 being the number of powers in each cycle. So 11 to the 11th power is just equal to 1 to the 11th power, mod 10. Then 1 times itself, 11 times, of course it will be 1, right? So, okay, it is quite easy to look now. We will have 11 to the 11th power. So this thing, when you want to find the last, so this thing will be equal to 11 to the first power, mod 100. And then easily 11 times 1 would just be 11 itself. So, okay, mod 100. Voila. So this is our answer. But, okay, the question asked last 2 digits of 11. So our answer is 11. So, okay, voila. Okay, shrink it. Okay, so this is quite a lot of stuff to consume. I hope it didn't take too much of your brain power. But yeah, so just to remind you guys, I'll be putting links down in the description for you guys to further understand this topic of modular arithmetic. Then again, I hope you guys learned a thing or two from me today, and I'll see you next week. So, ciao, tschüss.